And we have, I had put up an example, but there was another case where I wanted to provide one where the middle operation happens to be subtraction. And we have, just as a case in point, if you're looking at factoring a trinomial, okay, such as 10x squared minus 23x plus 6. Okay, and you're looking at factoring by grouping. Now, one could attempt trial and error, but the question would be, how could 10x squared be factored? Would it be 10x and x, 5x and 2x, or 1x and 10x, or 2x and 5x? And furthermore, with 6, could be 6 and 1, 3 and 2, 2 and 3, 1 and 6. And to take out a lot of the guesswork, okay, if you were to perform factoring by grouping, okay, again, you're looking at multiplying the first and the last coefficients together. Okay, so you have 10 times 6, okay, which will be 60. And where 23, or in this case, negative 23 is going to come in, you're searching for factors of positive 60 that will add up to minus 23. Okay, so how we got to 60 in the first place? Okay, it was multiplying the first and the last coefficients. Yeah, so we had 10 and 6, but in terms of adding together, we're not going to get negative 23 by any stretch. Okay, so we have 16 as the sum, and for numbers that will multiply into 60 and add up to negative 23, okay, we're going to have both of these terms must be negative. And okay, so we have like negative 10, negative 6. Okay, we had the sum to be at negative 16. So we want two negatives, but we want the sum to be negative 23. And for that combination, okay, we will have like negative 3 and negative 20, or negative 20 and negative 3, and those values add up to negative 23. And in terms of what to do with these coefficients, okay, we're going to split up, okay, the middle term, namely negative 23x, into first order x terms that will have negative 20 and negative 3 as coefficients. And it doesn't matter which one you have at the front between negative 20 and negative 3. We'll say we have minus 20 at the front, so you have negative 20x, followed by negative 3x, and we have followed by, okay, the addition of 6. Now if you notice, between the first and second pairs of terms, we have the operation of subtraction in the middle. And as we enter the stage of grouping the pairs in parentheses, okay, so the first pair we have 10x squared minus 20x. And again, we have with the middle operation, okay, we have subtraction. And when the middle operation is subtraction, it's the second grouping that requires a bit of concentration. Okay, what I mean by this, okay, for the parenthetical representation of grouping together the last two terms, which will represent, all in all, negative 3x plus 6, think of it like factoring negative 1 out from these last two terms, like we have with minus 3x. Okay, this is going to be the opposite sign of 3x. And in the case of positive 6, again, if you divide or take negative 1 into positive 6, you're going to have a minus 6. And just sort of backtracking, you see we have the right grouping. Just envision removing the parentheses. Okay, first two terms, okay, you have 10x squared minus 20x. And if I remove the second group of parentheses, okay, the terms inside will be affected by the negative in front. So you got minus over 3x, and minus over negative 6 becomes a plus 6. Right. Now, entering the stage of what we have in factoring. Now we have 10x squared minus 20x, and looking at taking out, okay, the greatest common factor, or the highest term that will go into both 10x squared and negative 20x. Okay, so the highest number to both 10 and negative 20. Okay, that will be 10. And between the terms we have x in common. And for taking 10x into the first pair, 10x into 10x squared is x. 10x into negative 20x, okay, that is going to be negative 2. And just moving down the minus sign. Okay, now between 3x and negative 6, okay, just kind of putting the prior items at bay and just looking at factoring 3x minus 6. Okay, don't look at what's in front of it. So between 3x and minus 6, greatest common factor, okay, that is going to be 3. And 3 into 3x minus 6, okay, that is going to be also x minus 2. And the 3 that was factored out, thanks to the operation of subtraction originally in the middle, that is going to be subtracted. Okay. And looking at what we have in the formation. Okay, so we have with both groups, okay, we have a shared binomial with x minus 2. And for what we have in the case of the other factor, this will come from clustering together the outside terms, those outside terms being 10x and what's going to be the subtraction of 3. And those would be your two factors. And the order that you place them does not matter, as long as you have 10x minus 3 for one and x minus 2 for the other. And you can go back and check or do a bit of double checking. So you have x times 10x is 10x squared. Here the outside product is negative 3x. The inside product, okay, you have negative 2 times 10x, which is negative 20x. Negative 3x minus 20x is a negative 23x. And negative 2 times negative 3 is going to end up as a positive 6. So those would be your two factors. Now, and factoring by grouping, okay, can involve multivariable expressions. And for what we have, say from page 41 or section R3, and we have in the case of number 77, no, I'm not interested in Epson photo print, sorry. Okay, so you have in the case of 77K, it already says for these exercises, okay, to factor by grouping. So things are set up whereupon we can factor by grouping. So we have these four terms in the mix. And so for what we have in the setup, okay, now we've got in the letters A and X. Okay, so we have the first term. We have 8AX plus 18A. Okay, we have plus 20x plus 45. first of all, okay, now for these four terms altogether, okay, now the highest term that will go into all four of these, okay, well, that's just going to be the number 1. Okay, so we got the green light, okay, to go ahead and factor by grouping. Okay, so we have pairing together. We have the first two terms. Okay, so you have 8ax plus 18a. And for what we have in the case of the operation in the middle, this time we have addition, so there will be no sign change manipulation with the last two terms. Give me just a minute. Okay, and for what we have in the case of pairing up, okay, so we have with 8ax, okay, plus 18a, okay, so you have even coefficients, and okay, and out of the numbers that would go into 8 and 18, okay, we're limited to just 2, and both 8ax and 18a, okay, share a in common, so the greatest common factor in this case will be at 2a, and dividing into 8ax, okay, so you have 4x, and 2a into 18a, okay, that is going to be at 9. We have plus, okay, now we have a 20x plus 45, okay, we don't have a variable in the common factors since we're looking at factoring the constant 45. Okay, so we're limited to just the greatest common factor being the highest number that will go into the coefficients 20 and 45, and we have that number at 5. And taking 5 into 20x plus 45, okay, so we have 4x plus 9, and so we have between the pairs, okay, we have 4x plus 9, it's common to both groups, and we have with the other factor, this can be formed by the terms on the outside. Okay, so we have the formation of 2a plus 5, and that will be the result. And again, if you were to multiply both of these binomials out and expand, you would end up with this 4-term expression. Now, we will look into the next item, 87. I'm going to tell you what, that one is kind of a drawn out scenario. So if we look on to number 90, okay, and here we have a single variable expression, okay, in the letter P. Okay, so you have the trinomial, okay, so you have p squared plus 8p plus 16, and so while we were dealing with a different letter as opposed to x, we're on a parallel course, okay, just as x squared would factor to x and x, okay, p squared would factor out to first order p terms, so p squared goes to terms in p, and we have filling in, okay, for the expressions. Now again, we have 16, okay, that consists of factors, and we're looking at those factors that will add up to 8, and we're going to have these to be identical for both p plus 4 and itself, and it's going to turn out that since p plus 4 is the only factor and it repeats, we thus have another case of a squared trinomial with p squared plus 8p plus 16 And for p plus 4 times itself, okay, we can condense this to the square of p plus 4. Right. Now, for what we have in the case of this one, a little bit drawn out, but 87 is quite a case, and we will eventually look into this. For number 91, okay, this is where stressing, okay, the greatest common factor will come into play. And here we have relatively high number coefficients, okay, whereupon we have the terms 50x cubed plus 160 x squared y plus 128 xy squared. And for this one, okay, so we have a trinomial, and this one can be factored, and there will be a couple of pathways. And the first will be taking the greatest common factor. Okay, so you have big numbers with 50, 160, and 128. And if I had just 50 and 160, you would have, like, the greatest common factor would have the number 10 for a coefficient, but with the 128, it kind of throws a monkey wrench in terms of the size of the coefficient of the greatest common factor. And with the 128, and since there are only so many factors, okay, that can be shared among 50, 160, and 128, okay, believe it or not, it only comes down to number 2. Okay. And in terms of the variables, okay, we have x and x cubed for the first term, x squared for the second, and just x for the third term. And there's no y shared unanimously in this trio, so the greatest common factor we have limited to just 2x. And taking 2x into this 3-term expression, okay, we have 25x squared, and we have 2 into 160, okay, that will be 80. X into x squared leaves us with x, and we have the y left over. And for 2x into 128, x y squared, so about 2 into 128 is 64. And we have x already present, and then we have left over is y squared. Okay. All right, so we have this to be partially factored, and this one can be expanded even further, and that is thanks to the fact that the lowered 3-term expression, okay, can be factored out by applying the factoring by grouping treatment. Okay, so just stepping to the side here, we have 25x squared plus 80xy we have plus 64y squared And if we look at factoring by grouping, okay, so we're dealing with larger numbers this time around. Okay, so we have with the first and the last coefficients, okay, we have 25 and 64. And 25 times 64, okay, so this will be at 1600. Okay, so we're looking for factors of 1600 that will add up to the middle coefficient, 80. Okay. Again, we have 25 and 64 to form 1600, but those numbers add up to 89. Okay. And now in the case of 1600, okay, 1600 has several factors, okay, but we need the combination, okay, that will add up to 80, okay. And it's going to turn out that, okay, 1600, this is a case where you have 1600 to be a perfect square value, and the square root of 1600, okay, in the case of the square root of 1600, if you add to itself, that's going to give you 80. And of course, that magic number is the big 40. Okay, so you got 40 times 40, 1600, and 40 and 40 will add up to 80. Okay, so we have, in the case of splitting up the middle term, okay, so you got 40 for the coefficients, so we have 25x squared, and we have 40xy, plus 40xy, okay, we have plus 64y squared. Okay. So we have 4 terms in the mix, and we can perform factoring by grouping. So we got the first pair, and we have in the middle, okay, so you have the operation of addition. We have plus the quantity, okay, so you have 40xy plus 64y squared. All right, so for what we have in the case of 25x squared plus 40xy, greatest common factor, okay, we have the highest factor coefficient for 25 and 40, okay, that is going to be 5, and both of these terms have at least an x in common, so the greatest common factor at the front is going to be at 5x, and into 25x squared plus 40xy, so you have 5x, and 5x into 40xy, okay, that will make 8y. We have plus, now for 40xy and 64y squared, okay, where the front terms had x in common, the back terms will have y shared in common, and the highest number into 40 and 64, okay, that is going to be at 8, so the greatest common factor is going to be at 8y, and taking into this last pair, okay, we also have 5x plus 8y and just doing a bit of color coding in case you have 5x plus 8y shared, and clustering together the outside terms in operation, we also have another 5x plus 8y. And with this factor repeating, okay, we have what's going to be the quantity of 5x plus 8y raised to the second. And so just bringing it all back. Okay, so you have 5x plus 8y quantity squared. And just finalizing the answer. Okay, and it does seem like a distant memory in terms of having factored out 2x from the start, but just for the complete answer of what we have for number 91, okay, 2x is part of the package, and for the rest, okay, you have 2x times the quantity of 5x plus 8y raised to the second. Yes.
So when you go back to where the blue is and you factored out the 5x and the 8y on each side, those just disappear?
Okay, what happens here, okay, is that what happens is that if you notice in blue, okay, that was shared, and once you get to the formation of the factors, okay, that which is shared, which I indicate in blue, that's going to be one part of it. And then in terms of the other factor, that would just come from combining.
Yeah. Okay, I see what you're doing. I see what you did. I'm sorry.
That's all right. That's all right. Yeah, it does. Yeah, I know what you're saying. It looks like just visually, you're seeing this twice, and you're looking at another 5x plus 8y. So I could see why one might be thinking that it's going to be like 5x plus 8y raised to the third. But just notice, any repetition here, it's going to appear one time. And the other entity will just come from clustering together the outside terms, which were the respective greatest common factors.
Thank you.
You're welcome. Okay, now for what we have in the case of 94, yeah, and there are some of those problems, and one reason I'm kind of holding off on 87, I believe it is, for right now, is that there are some problems out there, and I think 87 is one where the work can get a bit crowded, kind of to the point it can get to be more an exercise for the eyes than for just the procedure in just doing the math. And 94, okay, this is a little bit of crowding, has a little bit of a crowded effect, but not so bad. 94, okay, you have okay, just like 91, okay, you have two variables, but we're going from x and y to expressions in m and n. And for 94, okay, we have the first term is that 9 times m to the fourth, and we have plus 42 m squared into the fourth. And we have plus 49, okay, into the 8th. Okay, now, you can look for a greatest common factor. Now, in terms of the numbers, okay, we have 9, 42. Okay, and if we had just 9 and 42 to deal with, okay, now 3 would go into those numbers. But with 49, this is the monkey wrench that is kind of thrown in. 49, okay, you got factors like 1 and 49, and then you have anything else is that is positive. It's just the number 7. 7 goes into 49, and it goes into 42, but it doesn't go into 9. And when we had 9 and 42, 3 would go into 9 and would go into 42, but it does not go completely into 49. And so in terms of the coefficient, it is just the number 1. And also in terms of the variables m and n, okay, we have m present in 9m to the fourth and 42m squared into the fourth, but it is missing completely with the last term. And regarding the letter n, it doesn't even appear at all in the first term. So the greatest common factor is just 1, no variables whatsoever. So this expanded form, in essence, okay, this in terms of pulling out a single greatest common factor, single term, this is in simplified form, But in terms of factoring out binomial expressions, this is one where we can just go ahead with the factoring by grouping. And for what we have in this trio, okay, so again we had the first and the last coefficients at 9 and 49. Okay, so you have 9 times 49. Okay, so this is going to be 441. Again, so we're looking for factors of 441 that will add up to 42. So 9 and 49. Sometimes the numbers you start out with could be that combination we seek and it happens to add up to the middle coefficient, but this is not going to be one of those cases. 9 and 49 add up to 58. So just looking at numbers that will multiply into 441 and that will add up to 42. We have a little bit of history repeating because just like we had the square root of 1600 added to itself to get us to what was then the middle coefficient. We have another square root situation, and that is going to be with 21. Okay. We got 21 times 21 is 441, and 21 added to itself is 42. So here with the coefficients, okay, we can split up the 42 m squared and into the fourth. And again, we had the middle operation to be addition. So there'd be no sign change manipulation between the groups, so we don't have the middle operation of subtraction. Okay, so grouping together. Okay, so we have the first two terms with 9m to the fourth. Plus 21m squared into the fourth. Then we have plus. Okay, now we got 21m squared into the fourth. Then we have plus 49, okay, into the eighth. Okay, so this is what we have so far. Again, it's factoring by grouping, first, last coefficients, product of 441, combination that adds up to the middle coefficient 42. We have 21 and 21, and then splitting up into separate groups, and we have with 9m to the fourth and 21m squared into the fourth. So between 9 and 21, see the highest number here, okay, that is going to be at 3. And we have the letter m in common, and in the greatest common factor, okay, this will be the lower power to which m is displayed, and for the pair we have 3m squared. And into 9m to the fourth, we have 3m squared. And taking into 21m squared into the fourth, 3 into 21 is 7. We already have m squared into itself. And left over we have n to the fourth. And for the other, see, 21 and 49, let's see, got 7. M is not shared. We got into the 4th, into the 8th. Okay, so N is shared, and going with a lower degree, we got into the 4th. And taking 7 into the 4th to the last two terms, so we have 3m squared. And we've got 7, and into the 4th into the 8th is n to the 4th. Okay, so we have, again, so you have shared in common displayed in black. Okay, so you have 3m squared plus 7 into the 4th, and the other factor. Okay, so just color coding with green, those are the outside terms and operations. So we're going to have another 3m squared plus 7 into the 4th, and we have the same expression repeating. And since we have two of these, okay, this is going to come out to 3m squared plus 7 times into the 4th, quantity squared. Okay, so we have a case of another squared trinomial in multiple variables. All right, now looking at transitioning from working with polynomials, going from multiplication to factoring expressions in terms of squares. Okay, we do have, and it's kind of its own entity, where we have working with cubes. And in chapter R, now you're looking at sums and differences of cubes where you're given the formulas. But there is a section in a future chapter, okay, where we have what will be log and synthetic division that will kind of give you the foundation or the derivation of how these sums and differences of cubes are formed. So the other day we were looking at, like factoring binomials and trinomials second degree, where the leading term was x squared or p squared or y squared. Now with the sums and differences of cubes, on the side of what we have with sums of cubes, okay, so have a to the third plus b to the third. And the factorization of this, okay, you'll be looking at on the plus side, okay, you'll have the addition of the cubic roots of a to the third and b to the third. So we'll have a plus b, and we have with the other factor, this is going to be a 3-term expression. We're going to have a squared minus ab plus b squared. And just an example of taking the sum of cubes. If you're looking at factoring, so you have x to the third plus 64. Okay, now we have perfect cubes with x raised to the third as well as the number 64. Okay, so you already have in cubic terms, you have x cubed, which is the cube of x. Now for 64, okay, 64 is one of the special kinds of numbers. It happens to be both a perfect square and a perfect cube. Like 64 would be the square of 8, since 8 times 8 is 64, and it is also a perfect cube because in this case we have the cubic root of 64 is 4. 4 times 4 is 16, times 4 furthermore comes out to 64. So 64 is going to be 4 to the third. Okay, so if you were to follow through and follow in line with the formula, you think of like a is represented by x and b is represented by 4. And for a plus b, we have x plus 4. And for the a squared minus ab plus b squared part, okay, if you see it intuitively enough, okay, that's fine. I'm just going to add this somewhat intermediate in between step. So you got x squared representing a squared and minus a times b. So a is at x, b is at 4. If you go ahead and write that as minus 4x, you're correct, and that's fine. And for b squared, okay, b squared is going to be the square of 4. And for what we will have ultimately, okay, again, you have x plus 4. We have times, okay, so you got x squared. You got minus x times 4, which is going to be the subtraction of 4x, and 4 to the second. That is going to be at 16. Right. So we have, in effect, we have x cubed plus 64 is going to be the result of multiplying x plus 4 by the trinomial x squared minus 4x plus 16. Okay. So this is one sample of taking the sum of cubes. Now, in the case of the difference of cubes, okay, so we have a cubed minus b cubed. Okay, and so we have at the front, okay, you're going to have your two-term expression. So you'll be looking at taking the difference between the cubic roots of a and b, a to the third and b to the third. So that's going to be a minus b. And the trinomial is going to be of addition throughout. So this time we're going to have a to the second plus a times b plus b squared. And what I will do here, as an example, I'm going to throw in terms that will have somewhat raised coefficients. And we'll say that we have, so we have 27x cubed minus 8 times y to the third. Okay. Now I got 27x cubed. Okay. Now if you notice, we already had the exponents 3 for both of these. Okay. But now for 27x cubed, okay, that's going to be the cube of, we have a term times itself times itself. So you're involving the cubic root of 27. That's going to be 3, since 3 times 3 times 3 is 27. And x cubed is going to be the cube of x. Now for 8y cubed, okay, now 8 is a perfect cube, like 2 times 2 times 2 is 8. And y cubed is going to be the cube of y. So you got the cube of 3x minus the cube of 2y. So you could look at a as being set to 3x and b set to 2y. And if you follow it in line, a minus b, again, a is at 3x. You got minus b, which in this case is going to be 2y. And we'll throw in this extra stuff for the trinomial. Again, a squared is going to be representing the square of 3x. And if you're accustomed enough to do the exponents mentally without writing the extra stuff, that's okay. Now for a times b, we got 3x times 2y And we have with b squared. Again, b is at 2y. And that is going to be squared. Okay, so again, you have a minus b represented by 3x minus 2y. And then for the follow through, okay, we have the square of 3x, or 3x times itself. So this will be 9x squared. And we got plus 3x times 2y, so we're going to have 6xy. And for the square of 2y, okay, this will come out to 4y squared. Okay, and so we have in the result, okay, so we got 27 x cubed minus 8y cubed is equal to the quantity of 3x minus 2y times that of 9x squared plus 6xy plus 4y squared. And in the realm of working with cubes, so what, just for the next few moments, so what, let's see what we get. And this is part of the set in section R3. And so let's see what we get for factoring u to the third plus 343. So here we have the sum of cubes, and also with the difference of cubes, let's see what we get with the factors of 27 m to the 12th minus 64 n to the 9th. And we'll discuss in the next few moments. Okay, for what we have in the first, okay, we have u to the third, okay, plus 343, okay, and here we have the sum of perfect cubes, okay, and so we already have the cube of u, okay, so we have u to the third, and for 343, okay, I don't think this is a commonly used perfect cube number, at least I don't see it like 1000 or 64 or 27, but 343 in its own right is a perfect cube since it is the equal of 7 times 7 times 7. So I have u to the third plus 7 to the third so we got situated, we have a at the variable u, b with the number 7. So for the a plus b portion, here we have u plus 7. And for the trinomial portion, okay, so we have a squared is going to be u to the second. We've got minus ab. We have u times 7. And if you went ahead and wrote minus 7u, that's fine. And we have a b squared with b at 7. We've got 7 squared. And we have for the end results, okay, we have the quantity of u plus 7 times that of u squared minus 7u plus 49. Now for the for the second item. Okay, so we have going back to the difference of cubes. Okay, so for 27, m to the 12th minus 64 n to the 9th. Okay, so both of these terms are perfect cubes. Now for 27, m to the 12th. Okay, again, 27 is the cube of 3. And the cubic root of m to the 12th will be 1/3 the power of m to the 12th. So that is going to be m to the 4th. We've got minus. Okay, now the cubic root of 64 is going to be 4. And the cubic root of n to the 9th, again, will be 1/3 the power of n to the 9th. So we're going to have n cubed. Okay, so in this setting, we have A represented by 3m to the 4th, and B is going to be represented by 4n cubed. And so for what we have in terms of following through, okay, so we've got for A minus B, okay, so I have 3m to the 4th minus 4m cubed. And in the case of where we have the trinomial, okay, the a squared plus ab plus b squared, okay, this can get a bit analytical, I know. Okay, so you have 3m to the 4th. Your a squared is going to be represented by the square of 3m to the 4th. And your plus ab is going to be taking the product of 3m to the 4th and 4n cubed and for plus b squared, okay. And again, if you're accustomed to problems like these, you don't have to write this in between step stuff, but I'm just kind of taking things into auxiliary mode. Okay, so you got 3m to the 4th. So 3m to the 4th minus 4n cubed. And for the squares, okay, so we have for 3m to the 4th squared. Okay, so 3m to the 4th times itself, 3 squared is 9. M to the 4th squared. Okay, so you have m to the 4th times 2, so that'll be m to the 8th. And you have plus, okay, so you have 12. M to the 4th, n to the 3rd. And for the square of 4n cubed, 4 squared is 16. And n cubed squared will be n to the 3 times 2 degrees. So we have 16 n to the 6th. And that'll be the resulting factorization of this difference of perfect cubes. And once again, time and again, we will be looking at multiplying as well as dividing polynomials. And in the case of where we do have the operation of addition, so I mention what we have for rational expressions. And I'll start out with the introductory case. Okay, so you have rational expressions and operations. Now let's say we had just a couple of fractions to add. If you're accustomed to doing measurements, kind of like with a ruler, you might have fractions like 3/4 and 7/8 to add together. And to be able to add fractions of this type, okay, we need a same bottom number, or what they refer to as common denominator. So for 3/4 and 7/8, then if we put these fractions in terms of the least common denominator, and this will be the smallest number that 4 and 8 will go into, and that is already present, since the least common denominator is going to be at 8. And if I adjust what I have here with 3/4 and rewrite in terms of the LCD, so we'll raise 3/4 and put in terms of 8s, and to keep it in balance with 3/4, where it would reduce to the decimal value of 0.75, I'm just going to raise 3/4 and put it in terms of 8s. So think of it like this: 4 into 8 will go 2 times, and it will multiply this time, thus 3/4 by 1 in the form of 2 halves. So 3/4 is going to become 6/8, and added to 7/8, we had the same denominator, and I can add the numerators, combining. And so this will come out to 13/8. And you can leave as a fraction, whether you write as a mixed number like 1 5/8 or as a terminating decimal, that is optional. Now, let's say that if you have in the denominator, okay, say if you have variables of different degrees that are in the mix. And we'll say that we have 5 over 2x squared. Let's say we have 5 over 2x squared y plus 3 over 4xy squared. Okay. Now we do have variables in x and y, but not the same degree. And if I adjust both of the ratios in terms of the least common denominator, okay, so with the numbers 2 and 4, smallest number here is going to be present with the number 4. Now for x squared and x, again, you're going to go with the higher degree in the variable, so that's going to be x squared. Likewise with y and y squared. And altogether, the least common denominator is going to be at 4x squared y squared Okay, so we're looking at adjusting both fractions. Now for 5 over 2x squared y, okay, so if I take 2x squared y into the least common denominator, okay, so 2 will go into 4 2 times. We already have x squared in common. Now for y, if I take into y squared, we have 2y. So you're going to multiply the first fraction by 1 in the form of 2y over itself. And in the case of 3 over 4xy squared, just a slight adjustment is needed here. Okay, so we got the 4 And we've already got the y squared, but we're missing a degree in x, and x into x squared will go x times. So this second ratio will be multiplied by 1 in the form of x over itself. And so once we put together, okay, the denominator is going to be at 4x squared y squared and just combining the numerators. So you have 5 times 2y, that'll be 10y. And you have plus 3x. And you can also put this in alphabetical order. Either way suffices. All right, and so let me throw in this one more case here, and this is where you could be looking into prime factorization. Now, let's say if we have with this one, okay, so if I have, let's say 3 over 8 x cubed y squared. Let's say if I have plus 1 over 24xy. Then we have plus 2 over 27 x to the 4th, y to the 3rd. Okay, so we definitely do have different denominators present. Okay, and in terms of structuring, okay, what the least common denominator will be. So if we look at just the number 8, kind of do what is referred to as prime factorization. And prime numbers are those numbers where in the natural numbers, that is the positive counting numbers, it'll be that number times 1, or 1 times that number. So 8, we have 4 times 2. And we can reduce further the 4 to 2 times 2. So 8 is going to be 2 times 2 times 2. Now with 24, we start out with a combination, could be 2 and 12 or 4 and 6. And factoring out into primes, now 4 is again going to be 2 times 2. For 6, we're going to have 2 times 3. And for 27, we say we have 3 times 9. Now 3 is a prime number, and 9 can be reduced even further. We have 3 times 3. So this will be the prime factorization of what we have at 8, 24, and 27. Okay, so we have with the prime factors. We have with the numbers 2 and 3. And as for what we have in the case of the variable factors, okay, those are with the letters x and y. Now for the least common denominator, you're going to be looking at the highest representation or greatest number of appearances of each prime factor from any of these factorizations. Now with number 2, it doesn't show up at all in 27. It shows up 3 times from 24, and it does show up 3 times from 8. So the greatest number of appearances of 2 from any of these factorizations is going to be 3 times. And with the number 3, it doesn't come at all from 8. It comes once from 24, and it comes 3 times from 27. And as for the variable factors, we're looking at the highest degree appearance of x to be at fourth order. And with y, we got y squared y to the third. So y to the third is going to be the highest power variable factor in y portion. And looking at multiplying, so you got 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. And numerically, we're going to have 216. So you have 216 x to the fourth, y to the third. Okay, so looking at adjusting the fractions. Okay, so for 3 over 8x cubed y squared, okay, if I make the adjustments here, okay, so 8 into 216 is going to be 27. We got x cubed, but we're missing a degree, so you got multiplying by x. For y squared and y cubed, so we have y left over. For 24xy, 24 into 216 is going to be at 9. X and x to the fourth is going to make x cubed. We're just about there. Y into y cubed is going to be at y squared. And as for 2 over 27, x to the fourth, y cubed. 27 into 216 is going to be 8. And guess what? We already have fourth in x, third in y. And so piecing it all together. Now all three fractions will have the least common denominator formation at 216 x to the fourth, y to the third, and for what we have in the numerators. The first one we have 81xy. We've got plus 9x cubed. Y squared, and then we have finally 2 times 8, which will make 16. Okay, so this will be our consolidated ratio when combining this trio.